I'm welcoming you all to new software MvDad.com. MvDad is for the stable structural solutions. MV stands for Sir M. Viswesvaraya, India's greatest civil engineer. DAD stands for my father, Professor P.K. Karamchandani. In other words, M stands for moment, V for shear, D for deflection, A for analysis, D for design. MvDad.com. It's a unique one can operate on their mobile from anywhere, and it's free software for educational purpose. In this software, we can do the analysis, design, drawing, and it is most economical and gives all the results in detailed format, graphic. We will discuss on that very shortly. That per project, we require minimum data. We will start the new project so that you can understand how it works. Just we are creating the new project as a
Sir,
can
sir,
you
you
see
are
it?
on mute. Please unmute yourself. Yes.
Is it visible? Hello?
Yes, sir.
Yes, sir, visible.
Visible.
It's visible, no? Yeah. The minimum data which we require from the user to design the RCC building, we start with the, as per IS code, we require the seismic zone and seismic factor. For all over India, it is very difficult to remember. So what we did, we have made the library, and according to the state, district, and city, the seismic zone and seismic factor will be taken care by the software. Now we are considering the Kolkata, that it comes in the West Bengal. Seismic zone is 3, seismic factor is 0.16. Next, we have to select the building type. Is it commercial, hotel, office, residential, or school? According to the building type, IS loads 875, dead load and superimposed live load will be taken care by this software. In this project, we are considering residential, measuring units, feet or meter, ground plus number of stories. For regular buildings, as per IS code, it permits up to 13 stories, that is up to 40-meter height. Here we are considering 3 number of stories, ground plus 3. Floor height. We have the option to keep the variable height for each and individual floor. We are considering 3.5 meter from ground to first. And onwards, 1 to 2, 3 meter, 2 to 3, 3 meters, 3 to terrace, again 3 meters. Now, as per IS code 875, floor finish SIDL 3, live load minimum 1.5, but user can take them above that 1.5, but they are not permitted to go below 1.5. So one should be strictly follow the IS 875 for safety of the building. Same way, floors, we are considered 1.5, 1.5. For WC, 5 to similar way, we will proceed further. Now, wall. External wall, we are considering 0.23 meters, floor to floor height. Internal wall, 0.15 meter, one can say 6 inch, floor to floor height. And for parapet terrace wall, we are considering 0.15, height 0.9 meter. Now comes the plinth, meter above the ground level. We are considering 0.6. Plinth below ground level, one can go anything. Here we have 0.75. Soil type, soil medium, rocky, soft. We are considering rock. Till now, we have selected the data from the drop-down boxes. From the end user, just we are collecting bearing capacity of soil that one has to enter and nothing else. We are considering 300 kilonewtons per meter square. Now grade of concrete from M15 to M40, we are considering M20. Main steel 415 or 500, considering 415. As per the limit, and for seismic, IS port 1893, foundation as per the working stress method. We are proceeding further. Now, the data. In this case, we have two options. Slab data, either you have to draw as you are drawing in the AutoCAD. Second option is you upload the data in the form of Excel format. What exactly it is, I will show you. Excel format is nothing but this X coordinate, Y coordinate, X span, Y span, slab number. Here we are considering 3 slabs. We have entered the coordinates and span accordingly. The same data, how we are utilizing in the software, just we will show it. Upload the data, choose the file. We are uploading the data. Yes, data uploaded. For beam and column, we have other options. We will show you that also. Uploaded data we are selecting so that straight away we can proceed further. What we did, we are getting all these 12 to 13 data from the user, and we ask them to wait to get it verified by admin of the software. And what we do, we check it that data, is it correct or not. If the data is correct, then we give the permission to the user to upload to proceed further. And we are giving the rights to the user, what they can see and what they can't. We are permitted. Now we will see how it is working. Yeah. Yeah. We got the permission. Just we will check. the slabs are displaying. S1, coordinate 0, 0, in X direction 6 meter, in Y direction 3 meter. S2, 3, 0. That means it is very easy for the user just to upload the Excel format and one can proceed the data. Now further, for each and every floor, we will copy the data. For terrace, we will copy from the floor 1. Same way, floor 3, copy from 1. Floor 2, copy from first floor. Floor 0, footing, copy from first. On the all floors, slabs are drawn. Just we recheck. They are there. Terrace. Now we will create the columns. On. Just we have to click 2 times at the point where column we require. Here we get the option, the column from 0 to floor. In this case, we are considering from bottom to top for all the floors. Column 2 created, column 3 created, column 4 created, column 5 created, column 6. Now we will check it whether they are drawn properly or not. At ground floor, columns are there. First floor, second floor, third floor, and top. Now we are coming to the beam. This is the specialty of the software. The specialty is that just we have created the slabs and we have created the columns. Our software will take care of the beams as per the column position. Just we will check how it will be created. Auto beam generation, all floors, okay. Just on the click of the button, beams created. Just we will check. This is terrace, floor 3, floor 2, floor 1. Up to this, we require the data from the user. Nothing more from the user. Now, this we call auto modeling. The project which we have created, it took not more than 10 minutes. Now, this software will take its own course to analyze, design, software will follow these steps and full project will be ready. The project which we have created, shown how to create. Now we will see it, the same project which we have already created and analyzed, and it is available on the online domain. I am giving you the opportunity to just you log in as I am logging, just I will give you the demo AU. Sorry. Demo AU, your Adamas University. Password is your Adamas University AU. Small words AU. Just log in. Now full project, same project which we have created to show you how data to be entered in this our software. Now fully analyzed and designed project is in presence of you. Only these sub menus you have to choose, select float. On the same screen, nowhere to go, nothing to remember. These for the float. And this is for the plan and elevation. This is select module frame analysis at coefficient method. We are giving you the permission for the frame analysis. For slab, it is 2D frame analysis. For beam, it is 3D analysis. And for earthquake, it is finite element method. And this menu, these are the results which one required for the project. Slab dimension, they are available. Thickness, width, length, and effective depth. Same way, beam movement at the center of the column. We will see in the elevation, beam movement is 49.22 at the terrace floor at the center of the column. The same, if we see at the face of the column, beam movement should be less than 48.22. It is 38.22. Now what we did, mostly other softwares design the beam at the support, the value is for this 48.22. Whereas we are designing the beam at the face of the column according to the 38.22. That means that is the saving of the reinforcement. Right? Now we will go back. Beam dimensions. We will get the beam dimensions in elevation, in section, in plan, then beam shear, again elevation and plan. One can verify. Beam steel in XX direction. That means B1, B2, B3, B4, B5. These are in the XX direction beam. We will show you the beam steel. Top 2 bars, 12 mm. Bottom 2 bars, 20 mm. Plus 1 bar, 12 mm. Same way for beam 3. 3 bar, 25 mm. 1 bar, 12 mm. The results are there. Same results we will show you in other format also. Beam in Y direction. B5, B7, and B8. B6, B7, B8. Then column shear, column movement, again in elevation, column shear, column movement, column dimensions, column steel. Plan also one can see. This menu shows you the full results of the project. Now, this menu is for plus, enlarge, nothing else. Now we are coming to the elements. How this element, that means slab, is slab steel, project name, floor, slab number, date, section, number of bars, 8 mm dia, 200 mm, 20 bars dia, 8 mm at 160, main steel, secondary steel, the section X, section Y, the plan at bottom, plan at top. For each and every element, one can get the steel design. Same way for another beam, for another slab. Just you have to click on that element, you can see. Now, for full floor, one can see the steel design and the tabular format. Slab number, floor, one way, S1, floor 4, effective cover, effective depth, slab dimension, 3 meter by 6 meters, quantity, grade of concrete. Now, secondary steel along Y direction at top, 20 dia, 20 number of bars, 6 mm dia, main steel along X direction at middle span, 31 numbers of bar, 8 mm dia at 200 mm center to center. Weight of steel, which we require for the bill of quantity. Quantity of cement, that also we require for bill of quantity. At initial stage only, we have calculated the data. Now, how this element, from this element we got the result. This is the basically useful for the students. Full total calculation as we do for education purpose. Left support, right support, continuous, simple, their coefficient as per the IS code, then modification factor, LD ratio. Accordingly, we have calculated the effective depth, assumed effective depth, got the loads, that according to the load, we have calculated the shear, calculated the bending moment. Now, for this slab, full 2D frame analysis calculation is fixed end moments, their loading, their support reactions, moments, scale calculation. We will not discuss right now. Just I am giving you the introduction of the software, that what it provides you for your educational purpose, for your professional purpose, so that you can check it online from your mobile, from your laptop, from anywhere for any project. Then distribution factor, moment distribution, max min, min max, max max. IS code asks us the condition if the live load is less than this, so you can do only max min or max max. But for software purpose, what we did, we consider all the three cases, and according to that calculation, highest of that maximum of value of the we are considering. Usually what we do, dead load plus live load, and accordingly we do the calculation. But for the earthquake purpose, we require the 24 load combination. So from the initial stage only, we have bifurcated the load and the dead load and live load combination. And so these table calculations are in the two different format, for dead load and for the live load. Here we got the moment, here we got the shear, max min values, left support, right support. This shear value goes to the beam for the beam design purpose, and the maximum working moment and ultimate working moment, ultimate bending moment which we require for the slab design that goes for the 7.44. After that, we are calculating ultimate moment. According to the ultimate moment, we check the section is safe or not. If it is not safe, then we go on increasing the sectional sizes. In way, main steel as per the MU 7.43. Slab carrying capacity is 22.36. That is more than load on the maximum moment of the section as per the loading. That means it is safe what the section we assume, and accordingly we are designing the steel. Again, the full steel design calculation in tabular format so that students can understand and should follow as per the IS code to safeguard the structure. Steel provision 0.28%, 0.27%. Deflection check. If the deflection fails, again, we have to check the section. But in this case, it satisfies our condition. Then secondary steel. Same way, we did the calculation for shear, critical shear, check for development length, steel weight, number of bars, length of bar, spacing. As per the formula we have calculated, main steel is 64.3 kg, secondary steel is 74 kg, total steel 138.3 kg. This is the final result which we have shown you for the full floor. Main steel, secondary steel, dimensions, number of bars, cement quantity. Here we have covered slab design. Same way, we will see the beam and column. After that, we will show you how the load is transferred from slab to beam, from beam to column. This is load. We have considered the load, dead load and live load 3. Dead load is 3 and live load is 1.5 for the terrace. For other floors, it is 1.5 plus 1.5. Now, how load is transferred to the beam? Just we will click it. On this beam, from these two slabs, the load is transferred. On B1, load is transferred from the slab 1. On B7, load is transferred from the main load is transferred from the slab 2 and triangular load from S1 and S3. Same way, we will see the load on column B5 and B8. For C5, B4, B5 and B7. This is the last sub-menu. Just print. You can print out on the paper. Otherwise, on the screen, you can see the data. That means only this slab, floor menu, plan and elevation, and this select detail, and this click. One has to use only these sub-menus to get the results for that particular project. If you have any doubt, questions, queries, you ask me. If it is okay, then we will continue for the beam. Hello. Can you hear me?
Yes, yes, sir. We can hear you.
Yeah. Any query from the students or any doubt? So I can clarify them right now.
Students, sir is asking if there is any doubt, then please raise your hands and ask one by one. Sir, I think there is no query from student side.
Okay.
You may please proceed.
Yeah. Now we are coming to the beam. Just you notice B1 color and B2 color, they are different. B1 indicates left support simply supported, right support is continuous. So we have given the different color combination. One can see the plan and understand the end conditions of the end support conditions of the beams. Beam B2 is continuous, other simply supported. B3 is both sides simply supported. Again, B4 and B5, same way, left simple, right continuous. For B5, left continuous, right simple. Same submenu. This submenu is common for all. Just one has to click. If you are clicking on slab, you will get the slab submenu. If you are clicking on beam, then beam submenu. On column, column submenu. Step by step, we will go. Here I am showing you one other project. You can see the number of colors. And here combination is mentioned. Simply supported color, simply support other continuous color, both continuous, continuous, other simply support, cantilever, left cantilever, right cantilever. From here, one can visualize the end conditions of the particular beam. Just for your guidance purpose, that means no need to remember what end conditions we have provided and how it is working. Now we are coming back to the today's demo. For this, we will see the first shear force and bending moment diagram, which is our the basic for our civil engineering. One can visualize the values. Beam is 3D frame analysis. So negative moment at the support. By this 3D analysis, we are minimizing the mid-span movement. So minimum is still for the mid-span movement. We will check it, how it is. For B3, it is simply supported, that is both ends 0, 0. B4 and B5, simple continuous 3D prime. We will see Y prime. Just to here we are getting the point load from the B3, and accordingly loading conditions. When it is only simply supported, oh sorry, when it is supported on the column, then it is 3D. When it is resting on the beam, then it is simple support. Yeah. When resting on beam, then it is simple support. This is bending moment dead load, bending moment live load, bending moment max min, that means dead load plus live load, shear force dead load, shear force live load. You will get the display here for the shear force maximum. Again, the same menu. Support change, menu change. Nothing to remember. Now we are coming to the calculation. We'll see the field. Number of bars dia, full detailed drawing for individual element per beam B4. One can check it, view it. Self-explanatory from your mobile at any time. You log in and have a look. Same way for all the floors, results in the tabular format. Now the detailed calculation. We will see this frame and detailed calculation. Project name, beam number, floor, left support, right, left support simple, right support continuous. Again, the 3D, as per the 3D analysis, fixed end moment, bifurcated the loads in the dead load and live load format, calculated slab loading, beam loading, loading from the wall load, shear from the slabs, shear from the loading from the slab. Again, continuous, other simply supported, beam B5, left support continuous, right support simple. As we did the 2D analysis for the slab, for beam, we are doing the 3D analysis. Dead load, moment distribution, max min for live load, max for dead load, and for the live load. Moment, shear, detail calculation, At your leisure time, you can check it. We will go to the results. Results. Max min frame analysis. Column above floor, column below, beam at left support, beam at right support, column. We are getting the total maximum of fixed end moments, max load. And this is the live load. If you do the summation, it will come the maximum 51, 65.2, 22.7, 16.7, which we require for the designing of the section. Here we have calculated the bending moment. We are now calculating the shear. Left simple, continuous, continuous, simple. Finally, full detail calculation. From here, it will start the finite element method. Each and every section, the detailed calculation is done, which we are reflecting in the shear force diagram and bending moment diagrams. For degree level, it is not essential. Just we will skip it. It is good for the postgraduate and doctor level students. So we are skipping this finite element method for this particular demo. Here we will go that straight away results. This is the shear force for the beam B4 at the floor plan. And this is the movement. This is bending moment 23 minus 23.8 at the center of the column and minus 17.96 at the face of the column. MU max 44.28 at the mid span or at the distance of 2.4 meter from the left support. Here we are giving that distance. One can check it here also. Value 65.5. Here value 23.8. These are the required for the beam steel design purpose. Here we are designing. B4 is the L beam, it's corner beam, and according to the IS code, their width of flange is considered, ultimate moment is calculated accordingly, and the section is checked whether it is capable to carry the load. Here the carrying capacity of the section is 219, whereas the bending moment is 66.42. That means its section is safe. If the section is not safe, what we do? We do the reiteration. I will show you it later on. It will goes on increasing the sectional size. This is the autodynamic modeling. The section will be designed if it is safe. Otherwise, its sectional size will be increased. No way one will get the failure section. We have designed the software in such a manner that anyone can use it and the structure should be stable. For manual error, for calculation error, the section should not, structure should not suffer. This is the top steel, bottom is steel, full design. This we require for the 25 load conditions, so we have kept it this in the tabular format. Shear we require for the column design, and that movement we do. Just we calculated the steel here, and we have checked that percentage of the steel. Now we have to check the shear, whether section is safe or not. All these conditions, condition number 1, 2, 3, 4, as per the IS code, we have to check whether section is safe or not. Clause number mentioned, and the section is not safe, then we have to provide additional steel or we have to design this section. Worst case, the section is coming safe, provided 2 leg stirrups at 8 mm dia, 27 mm central center. Now this is check for development length. Again, it is calculated, it is safe. Check for deflection. Basic, otherwise the structure may fail. Then we increase the size. Just we take it. We have considered first 360. For then it is safe. Allowable deflection. Again, clause is mentioned, clause 23.2. This thing to remember, everything is taken care by the software. All this IS code 13920. That also we have incorporated and we have checked the sections width, depth, each and every aspect, whether it is as per the IS code 13920 or not. If it is not, then we are increasing the size of the section as per the requirement of the IS code. After that, again, quantity, cement quantity, which we require for the bill of quantity, weight of steel, weight of wall, steel weight is, main steel is 26 kg, and anchor steel is 41 kg, stirrup steel is 8.61, tabular format result, number of bars, which we have shown you in the graphic also. Total weight of steel is mentioned 75.85 kg for this beam. And this way, the shear is transferred to the column from this particular beam. We have completed beam part. We have shown you this full values in tabular format. Detailed calculations we have shown you. Steel load, how the load is coming. If you want to print that, whatever it is on the screen, that will be printed. Beam section, this elevation format. Plan, shear force and bending moment diagram. I hope I have covered all the points of the beam so that we can proceed with the column. Shall we proceed? Or any query for the beam?
Sir, I think you can proceed for the next section.
Okay, thank you. Same way, column. Total results and tabular format. Sectional size, quantity, main steel bars, steel stirrups, total weight of steel, tabular format, steel, drawing, sorry. C6, number of bars, stirrups, 8 mm, for each and every element. Just you have to click, get the data. Detailed calculation. Same way, load is transferred from the beams B5, B6, their movements, so that to find out the axial, uniaxial or biaxial. And everything is calculated and displayed to understand the design is correct or not. One can point out, we assume the section, area of the section, then percentage of steel. We are considering minimum 0.7, but IS code asks us not less than 0.8. So ultimately, we are designing 0.8%, and for that 0.8%, we do all the calculations, slenderness, and carrying capacity, movement capacity. We are going to check it. Carrying capacity of the section. Carrying capacity and section is set for axial load. Lateral ties, number of bars as per IS code 13920, scope, hoops, overlapping hoops, maximum spacing, stirrup dia, it should not be less than 8 mm. All the conditions taken care by the software, and everywhere it is mentioned the code and its clause. Check for least lateral dimensions, BD, whether a steel is practically possible to place in that section. Otherwise, the section should be revised. Step. Go to 240. We are considered 240. Cover unsupported length, effective length, axial strength, then axially loaded columns, full calculation, formulas. I have given you in everything in the tabular format. Just you have to enter 12 to 13 data to create the new project. And each and everything will be taken care by MvDad.com. Column story-wise stiffness and y-axis and x-axis, which we require for the seismic analysis. Beam stories-wise stiffness, up at the bottom, moment as per the 3D analysis, slenderness detailing, whether a column is slender or not. A short column, accordingly, it is designed. Now check for the movement. With quantity, at again 13920 number of classes from 7.1.1 to 7.4.6. All this we have taken care, and accordingly the section is checked. Total result. Column number, floor, column height, effective cover, grade of concrete, grade of steel, dimensions 240 by 200, number of bars, main steel, stirrups, 17 number of stirrups, 8 mm dia, total weight of steel 17.3 kg. We have covered the slab, then beam, then column, footing. Again, same way, Same menu, sub-menu for all the flooring, footing results in tabular format for each and individual section. Detailed calculation. Yeah. Data column above footing is size B450, B700. Minimum depth of foundation we consider. Properties of base size. We have considered the working load method. Instead of ultimate load, we are considering working load as per the IS code, and accordingly, the footing is designed, area of footing required, that is calculated, then depth of footing for bending moment acceleration, required effective depth for bending about x-axis. How this software works, that is, we can show you. Here we consider 300 mm depth. For this, we are take depth for footing from two-way shear consideration at peripheral section as per the formula, and then shear resisted by concrete design shear, and it fails. Carrying capacity is less than the design capacity. So we are revising the section. This is the reiteration. So we are increasing the size for additional 100 mm. And according to that, we do the again the design the section and recheck that from all the above conditions. Then we'll see how many times the number of loop is working. Counter loop starts 300 plus 100. Again failed. Counter loop ends. Here it is. From 300 to 400 and 400 to 500. Two times reiteration. When the section becomes the set, then we move further. Rough bar, take one way for one way shear. Steel, flooring, these are the results in tabular format and graphic format we have already shown. That means for each and every element, we are displaying the detailed analysis, detailed design, how the results are arrived, by which method, under which IS code, and then we are displaying the results in tabular format as well as in graphic format. This is the basic requirement for the graduate level students and for especially earthquake or structural engineer. This is the basic requirement for any structure, how to design as per the seismic IS code 189P. To see the beauty, whatever we are selecting, accordingly, that menu is displayed. Now we are selecting earthquake. That's earthquake menu, sub-menu is coming. Eccentricity, results, 3D, torsion. We will see one by one. This is the center of rigidity and center of mass. Both are displayed, both values are shown. Floor wise, how it works. See, the value is different, varies. For terrace, for third floor, values different. Terrace. Same way we will see the eccentricity. Floor wise. These are the results. How these results are arrived, we will see the detailed calculations of earthquake analysis also. Just you have the look on this menu, what we are showing in different format, so that one can understand that how these results came from the calculation. Now, torsion. Drift. Can you see this dotted line? Dancing dotted line, left, right. It's nothing but the displacement of the frame. And here you see the value, seismic load in the horizontal direction or lateral directions, whatever you can call. Floor wise, these are values. I will show you that calculation also. Now drift in y direction. Values are different for x and y. Torsional shear in x direction, torsional shear in the y direction. We have seen the results in the graphical format. Now we will see the detailed calculation of the earthquake analysis. Here, earthquake detailed calculation of project demo AU for seismic zone wise up to 40 meter if the building is regular. For this residential building, as per the stiffness, column shear walls, torsional effect, height and everything we have calculated. As per IS class 1893 part 1 2002 class 7.4, reduced live loads are used for the analysis. 0 on terrace, 50% on other floors if superimposed live load is less than 3. For the ground floor, for first floor, second floor, third floor, and terrace. As per the live load conditions, 1. SIDL, SILL. For terrace, we have considered 0. And for other floors, 1.5 less than, so we have considered 0.75, 50%. The SILL is less than 3. Slab load is considered according to the IS code conditions. Slab, total slab weight, floor wise is in this tabular format. And beam weight as per the column, as per the wall load and weight of wall, column load, sectional wise, floor wise, tabular format. Then we are calculating the earthquake total loads floor wise. 0, 1, 2, 3, 4. Weight of slab, weight of beam, weight of wall, column, total weight, total floor height. Mission data. Initial stage, we enter the data, West Bengal, Kolkata, seismic zone 3, and seismic factor 0.16. That means whatever data we have collected from the user, they are required somewhere. Without that, we cannot proceed to evaluate the project analysis and do the design. Now, as per the seismic factor, we are calculating earthquake loads in x-axis direction. Again, the formulas and the corresponding values we have entered. 5% damping is considered as per the IS code. Importance factor, type of building, residential, importance factor is 1. Response reduction factor R5. Seismic zone, seismic value is 0.16. Horizontal load, as per this formula, we have calculated the horizontal load VB 138.904 kilonewton. Same way for y direction, that is in the tabular format, floor wise. Now calculation to determine center of mass of the building. Applies the weight of slab, area of slab into load into slab per meter square. Accordingly, we have calculated, we have got the center of mass. Now we are considering center of stiffness and design eccentricity is given by as per the IS code 1893 plus 7.9.2. By these formulas, we have calculated the data are displayed in the tabular format. Each and every step is displayed that how we arrive that value. So one can understand the basic requirement of the designing and analysis of the structure. Here we got the center of mass and center of rigidity floor wise, and which I have shown you in the graphic format. These are in the tabular format. Up to here, it is as per the coefficient analysis method. And from here, this is the dynamic analysis by response spectrum method, mass matrix, the loads which we have calculated, seismic loads. These are the detailed calculation for graduate, undergraduate level. This doesn't require, but in our software, we have provided all this just to go through it so that we can find out the stiffness and the time period of multi-degree of freedom by the Eigen equation, Rayleigh theory. For this, the exclusive software comes which are used by a number of the software agencies. But whereas from scratch, we have developed this, we are using it online. Maximum, I feel, they are desktop-based software. They are not mobile friendly or online friendly. Our unique one can work from anywhere. We have find out the natural frequency as per the dynamic analysis method. And as per the dynamic analysis method, we have calculated the natural frequency time for multi-degree of freedom to calculate the modal participation factor of this. There are two methods, again by dynamic analysis method are under two procedures, SRSS, square root of sum of squares, and another is complete quadratic combination. This method is calculation of modal participation factor is as per the SRSS method. We have found out 5 degree of freedom. But whereas IS code requires number of modes up to 90% of the total weight is considered for further evaluation. In this case, mode 1 49, mode 2 38, that means again it is less than 90, and mode 3 is 22. That means up to 90. So we are considering 3 modes, and according to 3 modes and their time frequency, the lateral load calculation by modal analysis, sum of square root of sum of squares. In that way, we are calculating the lateral shear, lateral force and shear force. These are calculated. And another method is CQC method, complete quadratic combination. Again, these matrices like ith mode, this you will be taught by your faculty. They are much more capable than me to explain you how to do it. Here we are providing the full solution in detail. Shear forces by CQC method. Till now, we have found out the lateral force and shear force by 3 methods. One is equivalent static method, another is CQC method, third is SRSS method. Again, as per the IS code, we have to enhance the value of these as per the seismic force obtained above by dynamic analysis should be scaled up as follows. This 1.7 times if we compare with the equivalent static method. So in this case, by SRSS method value 27.54 is scaled up by 1.7 times. And this is the final value which we require to see, to check the drift and displacement of the structure. That means by step, we have to calculate the, and that results which we are getting should be used for the drift and displacement taking. This is the ultimate dynamic analysis response spectrum method in x-axis direction. For IS code, as per IS code, this dynamic analysis by response spectrum method is permitted up to 40 meters. If we go above 40 meters, then they require to be followed by pushover analysis. So we have kept the software for 40-meter height as per the response spectrum method. Now we are coming to the calculation to determine static eccentricity and design of eccentricity of the building. Again, as per the formula, this detailed calculation is shown. Their stiffness, column stiffness, beam stiffness, and floor-wise stiffness, everything is taken care. And their total maximum of that positive and negative, direct shear plus torsional shear. These values are there. Here we have calculated the floor-wise drift and floor-wise displacement. X direction and the shear force, lateral force, and shear force as per the response spectrum method. We check out the stability indices of the structure. Again, as per the formula, we have to see that whether the section is sway or non-sway. If it is more than sway, if the displacement drift is more than 0.04, then it comes under the sway. If it is less than, then non-sway. Here we are showing you that two tables, calculation of stability indices in XX direction as per the equivalent static loads method. And second table is yellow mark calculation of stability indices in XX direction as per the seismic weight method, that means response spectrum method. For user purpose, so that one can check whether which one is better. In both the cases, our displacement is less than 0.04. That means non-sway. This is for the X direction. Full detailed calculation again for Y direction. Just we are skipping it. We'll go to the final result of the timetabular SRSS method, CQC method, Y direction, shear force, and lateral force, their displacement. Y direction also, it's non-sway in both the cases, as per the equivalent method also, and as per the response spectrum method also. In any case, if it comes the sway, then we have to follow IS code for load combination. That means 25 load combinations. These are the 25 load combinations. Our case, our structure is non-sway, then there is no need to go for the load combination calculation. If I am wrong, then please correct me whether 25 load combination is essential for the non-sway. We have covered slab, beam, column, footing, and earthquake. We have shown you the results in the tabular format, the graphic format, shear force diagram, bending moment diagram, in plan, in elevation. Now we will come to the material, bill of quantities, material and steel. For this full project, how much steel is required, floor wise, grade wise, element wise, for slab, for beam, for column, for footing. Each and everything is calculated and shown in tabular format. Slab steel, floor wise, dia wise, and beam steel, floor wise, dia wise, and total beam steel, slab steel, total column, footing. Now, floor wise, we have shown. That means at the time of execution, how much steel is required for footing. Accordingly, the builder or developer can place the order for footing, for floor, For floor required slab, beam, column, steel, total grade, wise total, overall total. One can export the table in Excel format. Same way, material, cement, floor wise and grade wise, for slab, for beam, for column, for footing. Nowadays, we are using ready mix concrete, so we have kept the in the cubic meter format, and for total, otherwise one can convert it in the bags format also, as per the grade of concrete. In this case, 458 bags, M20 grade concrete. One can export it in Excel format. We have covered all the points. Yeah, one thing I forgot, project data. The data which we entered, one can verify the what we entered and what we are getting the results as per the data, or something is wrong by human error or entry level error or calculation error. By any case, we have considered building type, residential, unit meter, number of stories, floor height, then SIDL, SILL, wall, external wall, internal wall, parapet, earthquake, West Bengal, Kolkata, zone, foundation, rocky, grade of steel, IS code, walls. That also one can see. Here one can get the color wise. What type of wall is considered? That means just we enter the data, what type of wall is there. For external wall, it considers the 0.23, and for internal wall, the value is accordingly. And for the terrace, let's see. Just you see, no internal, only external periphery. What we did, we have given you the maximum output by getting the minimum input from the user. In our software, we do the analysis, we do the design, we provide the drawings, and fully automatic modeling. Otherwise, it is very difficult to do the modeling. And for that modeling, one requires the professional engineer to enter the data and get the results. As per my experience, I never got the same results for the same project if I entered the data at the different places at the different time. Some or other way, by intentionally or unintentionally, by human error, we forget or make the error by entering the data. But in our case, when you enter the 12 data, at any time you will get the same result. I hope I have clarified about the full project, how to be evaluated on this software. And here one can go through the IS code. Online they are available. Just you click, you will get, you can download IS code 456, IS code 1893, 1390. Nowhere to go. Everything is under one software. I hope I have explained each and every aspect of this software, and for anything, queries, basic ideas, suggestions or contributions, they are most welcome so that we can upgrade and update for the future students. They can be benefited from this software. Thank you for patience hearing to understand this new concept on online webinar. Thank you to professors. Thank you to teaching staff. Thank you to the students. Thank you especially to Dr. Tencel, who took the initiative and arranged this webinar. Yes, sir. Anything from my side?
Thank you very much, sir. Sir, we have one student raised his hand, Sayon
Yeah.
Bera. I think you
Yeah.
want to ask something.
Yes, please go ahead, Mr. Sayan.
Sayon, you can unmute and ask.
Very good afternoon, sir.
Very good afternoon.
Sir, it will be payable or like non-payable apps. So I mean software.
For students, it is free.
Hello, sir.
For students, it
हाँ.
is free. For students, it is free.
अच्छा.
Now, whatever this demo we have shown, no, they are uploaded and it is online. Just you have to enter that password. That's all.
Okay, sir. Okay, sir.
Just you go through it on your mobile. I will give you just. Can you see this?
Yes, sir. Yes, sir. Yes, sir.
This is project name.
Okay, sir. Project name.
Password is.
Password is.
I am giving it.
Sir, just. Sir.
KD.
Sayon,
Just.
what we will share with all of you.
Okay,
KD.
okay. Okay, sir. Okay,
Okay,
sir.
I will pass it on to you.
Okay,
Yeah.
okay, okay.
Okay.
Okay, okay, okay. Thank you, sir. Okay. Thank you, sir.
Anything else?
Good afternoon, sir.
Good afternoon.
Sir, I'm Asmita from fourth year.
Okay.
Sir, if I want to reconstruct any building, so can I use the same software with same password?
No, we are giving password for individual projects.
Okay, sir.
Right?
For every construction, we have to get a new ID and password.
Exactly.
Thank you, sir.
Yes, sir.
Anyone? Anyone else want to ask any question?
I uploaded same projects in the name of KDemo and Demo AU. And passwords are there. 3 levels passwords are there. For undergraduates, you can give KD1, KD2. And for postgraduates, for who are seriously interested in seismic, then KD and AU. Level 1, level 2, and level 3. Even right now they can enter and they can check it. Whatever the demo we have shown, no, it is available.
Sir, it was a wonderful demo that we have seen from your side. It's really nice to experience how easily we can do our work just by going into Google. It's really amazing that you have introduced to MvDad. It's really nice.
Thank you, sir. Thank you.
Thank you.
Thank you.
and I'm sure it will be great help to our students, whether they
Definitely,
are using for 1 kilometer.
definitely.
Really,
Even if you are a, you must be giving some project for the structural design students.
just
They
use
can do it on our software.
yeah, that's what the application of this website will be.
Yeah, just to share the data with me, I will upload that software. That means with the result, and I will share the password to you. For full one academic year, it will be available for them.
Surely, sir, we'll get in contact with you after this.
Yeah, so nice. Thank you.
Thank you, sir, for your valuable time. It was really a wonderful session, and we learned a lot of things how to design using MvDad software. And in fact, the great advantage is this is an online platform. We can use this at any place by any use.
Yeah, on mobile also.
Yes, yes, sir. Sir, with
And
this note, I
no
would
need to
like
purchase
to
any
share
other software.
one. Yes, sir, you may proceed.
Yes.
Sir, with this, I want to show you. I
Thank you.
think.
So nice.
This is a little token of thanks from our side to you, sir.
Thank
It's
you.
been
Thank
really
you.
Yes, sir.
nice.
This is a little token of love and respect. We will share this with you, obviously, through your mail.
Thank you. Thank you. And please share me the video also so that I will upload it
Obviously.
on the website so all other can use it.
Sure, sir. We have recorded
Yes.
your session entirely. We'll
Yeah.
share it.
Thank you. Thank you. So nice of you. Thank you.
Thank you, Karamchand ji. It's been wonderful for us to meet you and get your knowledge shared. And our students got showered of knowledge altogether, I believe. Hopefully, they will start working on and see the entire software, how it works. And if they have any doubts, we are making it as one set of questionnaire and share it to you, sir. Please help us if the student have any doubt.
Sure, 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 sure.
Sir, and the appreciation is just token of love from our side to you.
Thank you.
And
So nice of you. Thank you.
we know that you have a lot of honors, and we thought that it will be another honor to you from our side, sir. Thank you so much for this session, sir. And it's been really engaging and enthusiastic session from your side. Even I thought I need to call you maybe around 60 plus young. That much spirit you have shown to us. Thank you so much, sir. Thank you. Sir,
Thank you,
anything
sir.
last word from your side, you can share it, sir. Open to you, sir.
No,
Thank you.
just I want the feedback if anything is wrong from technical side or from the user side or any additional ideas, if they can share with us so that we can upgrade and update that also.
Sure, sir.
Yeah.
From your working, some of my student and faculty started working as hands-on, and they started working here itself, sir. They whatever they identified and whatever trouble if they face, we'll come back to you for troubleshooting, sir.
Thank you. No, so nice. My email is there. My mobile is there.
The software to improve, and if any help required for our side to improve our knowledge in the software, we are coming back to you, sir.
Most welcome. Most welcome.
Thank you so much,
Thank
sir.
you.
Whenever you are coming to Kolkata, you have another home away here, sir, Adamas University. Please visit
Sure.
us, and let's have a good celebration here, sir. Always, your visit is
But
celebration to us every time, sir.
Same
Whenever you are
way.
visiting, please let.
Sure, 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 sure. I will let you know if I come to their side. If you come to our side,
Sir,
you are also most welcome.
sure, sir. Sure, sir. It's really an honor to us, sir. Thank you so much, sir. Thank you.
Thank you.
Thank you, sir. Take care of yourself, sir. Thank
Yeah.
you. Thank you, sir.
Thank you very much.
Thank you all the participants for being here.
Thank you, sir.
So this is the end of our program today, and we are going to held lot of new programs in upcoming weeks. So expecting you all to be present with us and to cooperate us. Thank you very much.
Thank you very much. Thank you very much. We can call it a day today. Thank you so much to all the students and all the participants who were attended. Thank you and good day. You can leave the meeting now.
Okay, thank you, sir.
One more information after today end, by today end, we'll be sharing the feedback link. So make sure that you put your feedback.
Thank you.
Thank you.
Sure, sir, sure.